Lighting logic. Why? Brighter isn't always better. The project was a disaster. Complaints about the lighting were endless. The contractor says that whipped out the fixtures. Nothing changed. They doubled the wattage. Still no improvement. It was not until they finally measured the road level illuminance that the truth came out. The road had systemic blind spots, bright on the edges, dark in the middle, with highly rhythmic patterns of shadow. The problem was not THE lamps, it was the poles. 1. Geometry over power. Many believe that if a road is dark, you just need a brighter light. That logic is flawed. The coverage area of a light beam is dictated by mounting height, not wattage. If your pole is too short, high wattage only makes the roadside blindingly, but as well the center of the road remains a dark zone. The industry standard, the 0.6 rule. Your pole height should be at least 0.6 times the road width. 2-lane rules. Pole heights should be 6 to 8 meters. Urban secondary roads. Pole height should be 8 to 10 meters. May Aries 18米加 Pole height should be 10 to 12 meters. Or utilize a dual-arm central layout. This isn't a brand issue. It's a geometry issue. 2. The spacing trap. The second issue is longitudinal spacing. The golden rule. Spacing should not exceed 4 times the pole height is less than or equal to 4h. Exceed this limit and your uniformity collapses. You get the zebra effect, alternating bands of light and dark. For a driver, eyes constantly dilating between these ears. Zones isn't just a visual nuisance. It's a major safety hazard. Many budget-strapped projects try to save money by reducing the number of fixtures and stretching the distance between poles. The result, minimal cost savings, but a total failure in lighting quality. 3. The glare factor. The shorter the pole, the higher the tilt angle required to cast light forward. This forces the light source directly into the driver's line of sight. The simple test: stand on the road and look ahead. If you can see the light-emitting surface of the fixture directly, your pole is too low. This isn't high brightness. It's an incorrect installation angle. The reality of blind installations. We see these 3 mistakes most often in rural electrification and local government tenders. Poles are chosen based on what the neighbor used, or the supplier's default. Quote, no one measures the road. No one runs the calculations. The lights turn on, and the project is signed off. The professional 3-step workflow: vary the road width, calculated to the minimum height, using h is greater than or equal to 0. 6. West. Calculate the spacing. Set the maximum limit at s less than or equal to 4h end. Optimize fixture count within that range. Post-completion verification. Measure the actual illuminance on-site to create a data-backed baseline for DDVR maintenance. This process isn't complex, but it's the difference between a project that truly meets safety standards and one that just looks bright on the surface. True lighting quality is measured in the center of the road, not the curb. Have you ever managed a project plagued by dark zones? What was the root cause you eventually uncovered? Let's discuss in the comments.